Hi, I'm Sarah Tilley from Curious Maths. In this video, we're going to be looking at finding a fraction of an amount. Now, this objective in England actually comes in Year 2 in Key Stage 1, where children find half of an amount and a quarter of an amount. But it really gets developed into Key Stage 2, where children are actually asked to find much more tricky values like 5/6 of 72, and it actually builds up to finding a percentage of an amount later in the Key Stage. Lots of children find fractions tricky, so with this objective, they have to actually apply their knowledge of fractions to another context, and for some children that can be a little bit overwhelming. So in this video, I'm going to show you a really great approach, which is actually mostly based on a pictorial that's really going to help your child understand the fraction part of it, the amount part of it, and actually the process of what they're doing. This is the amazing bar model. I wonder if you've heard about it. So it's used across the world. It's particularly successful in Singapore, in China, in Japan, in America, and in England we've been using it for several years. It's called a bar model because it's made up of rectangular bars, and they are simply a visual representation. It's particularly successful with problem solving, but also with this idea, fractions of amounts. Now, usually in a bar model, the top bar will represent the whole, and the second bar will be divided into equal parts. And in this example, these are all thirds. And we're going to use this bar model to help us solve a fraction of an amount. Okay, let's get started with finding fractions of an amount. So here is the question, 1/3 of 15. Now you might be looking at this and vague recollections going on in your head from school, secondary school actually, where you might have remembered that you had to divide by the bottom and multiply by the top. So actually that is what we're doing, and we're going to show that maths in the diagram, but we're going to make sure we use far more accurate mathematical vocabulary. The beauty of doing it this way is it's a fallback, because if you can't remember that you have to divide by the bottom and multiply by the top, then this is an enabler. It shows you what to do and you learn from it, and hopefully then you remember more. So 15 is our whole. So we put 15 in the top bar. And now we need to divide our second bar up. When I'm finding thirds, I divide by 3. So I'm going to divide my bottom bar into 3 parts, and I'm going to try and make them as equal as possible because that does matter. There we go, not bad. So these are my thirds. This is 1/3, 1/3, and 1/3. It doesn't matter which third I use to answer my question. In school, I might start this with counters. I might put this on a big piece of A3 paper and give the children some counters to represent the 15. But actually it can be drawn just as well. And this is how we would do it. We take our 15 and we're going to divide it into the 3 parts. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. I've shared my 15 equally. I want to know how much is in 1/3. So I label my bar model with 1/3 and I count how many are in there. Now you'll notice when I was doing the dots, I was attempting to put them in the pattern of a 5 on a dice, just so children can sabotage, see quickly without calculating how much is in each box. 1/3 of 15 equals 5. Now I don't leave it there. To build on children's understanding, I want to see if they can actually now think, if they know 1/3 of 15 is 5, what is 2/3 of 15? Using the same question, the same diagram, building on what they know. Now, it might be that they say these 2/3. They can label the bar model. Now, the brackets are quite optional, but when a school uses bar modelling, they do tend to use brackets because we use them as a label. We use bar modelling a lot for problem solving, and this is helpful then. So I tend to use the brackets because I use bar modelling in lots of different maths. So 2/3 of 15, I can count and I can see it's 2 lots of 5, which equals 10. And the next question I definitely would ask is, what is 3/3 of 15? And I'm looking for your child to say straight away, that's a whole. So we're connecting the 3/3 being equal to the whole. We can see that in the diagram. And that, of course, is 15. Let's look at a slightly more tricky question because the value is increasing. We've got 42 this time and we need to find 5/6. Now, drawing 42 dots out isn't a very economical use of time. So once your child has had a bit of a practice with the kind of questions with smaller numbers where they could draw the dots and really get an idea that they're dividing the whole into that number of parts, then they should be able to make links with their times tables and their division tables. And by the time we get to questions like this, we're not really wanting them to draw dots. We'd rather them to use what they know. So 5/6 of 42. When I'm finding sixths, I divide by 6. So I'm going to divide my bottom bar into 6. I'm actually going to divide it into 3 first. And then halve that third to make a sixth. And these are the sorts of things that you can be talking to your child about whilst you are doing it. Now 42 is my whole, so I write that at the top of my bar model. And I've divided it into sixths, and I need to find 5 of them. So in the dotty approach, we would dot 42 dots into the boxes and see how many we had in each, and then see how many we had in 5 of them. But we're going to use our division tables to help us do it. We can see that we have 42 and we need to divide that by 6. And what's often helpful if your child's struggling to know the answer is to ask them how many 6s in 42, and they can count in their 6s until they get to 42 if they need to. And they will find out that there are 7 6s in 42. So each of these parts is worth 7. So we can fill the digit 7 in each of these parts, like that. The question is asking for 5/6. So we can label 5 of those sixths like that. And actually, in school, sometimes get children to sort of shade it in. 2 sixths, 3 sixths, 4 sixths, and 5 sixths. So I can see, my diagram tells me that I now need to do 5 lots of 7. And using my 5 times table rather than my 7 times table, because that is easier, I know that that is 35. So 5/6 of 42 equals 35. And as you can see, we have done that 42 divided by 6 times 5. That's actually what we've done, but we've slowed it down and we've supported it with a diagram. Once your child has correctly solved 5/6 of 72, I would then get them to think about other questions. They've already drawn the diagram, let's talk about it. So 6/6 of 42, tell me what 2/6 of 42 would be. How much of the bar would you shade in if it was 3/6 of 42? Ask them if they can spot that 3/6 of 42 is the same as half of 42. There's lots of work you can do around the one diagram. So the way I like to teach is not just rush on to the next question all the time, actually use one question and ask lots around that. And you could even go to 7/6 of 42 to see if they instinctively recognised that that would simply be another 7. Here is a summary of the main teaching points when finding a fraction of an amount. Use a bar model so that your child can actually see the maths that's going on behind the calculation. It gives you a really good opportunity to talk about fractions, their relationship to the whole, and also to build on a question. You'll notice in the video, I gave one question from a bar model and then gave another and then gave another. Encourage your child to draw dots, but as soon as you think they're ready, let's get them using that division knowledge to help them calculate fractions of an amount. It's really quite important to try and make sure that children use, particularly for this maths idea, equal size parts when they're looking at the whole. 1/3 needs to be the same size as the next third. That's really important.